Okay, so this one we have sheriff calls. So the dispatchers at a sheriff's office record the total number of calls received since 5 a.m. in 3-hour intervals. Total calls for a typical day are given in the table following. So in this table here on the bottom right. And what we're supposed to do is write an appropriate model for the data with input aligned. So x is equal to 3. So here we have 3, 6, 9, 12, and 15, 18, 21, 24. Okay. And so we're supposed to find a model for that. And then after that, determine the rate of change at noon, 10, midnight, and 4 a.m. All right. And then discuss how rates of change might help the sheriff's office schedule dispatchers for work each day. Okay. So first off, what we have to do is find our model. And so what I'm going to do is go over to our calculator and I'm going to plug everything in. And now because it takes a long time to type it in, it's there already. And so let's look at this. How does that look? Well, it looks like it's coming up, it has a point of inflection, and then it's kind of leveling off. So those, when they have leveling off at both ends, are usually logistic. So let's see what a logistic model would look like. So if we arrow over, logistic is over here. Let's put that in vars 1, 1. What? Vars 1, 1. There we go. And so now if we do that, that's what our model is. So let's write that down. Okay, let me get it down here. 3.25. We'll go out to 3 decimal places, I guess. Now let's look at a graph. Okay, that looks reasonable as far as how it goes. So we'll call that good. And so now let's go back to here and we can write that model down. So let's let A and let's call it, I don't know, sheriff's calls. So I don't know, S of X or something like that maybe. And so let's say that was equal to, that was 1342.077. That was over 1 plus 36.797 e to the negative, and that was 0.259x. Okay, and that's going to be the number of calls received at the 24-hour period. So that whole thing. So we'll just label it as calls, and again, it's from 8 a.m. to basically 5 a.m. Okay, so 24 hours there. All right. Now, the next one says we need to determine the rate of change at noon, 10 p.m., midnight, and 4 a.m. Well, before we do that, that means we have to find the derivative, okay? So our derivative, now this whole thing can go up to the top, remember, and be a -1. And so it looks like, remember, with logistic, we're going to have 3 parts. And so trying to get all the parts here, let's see here. Let's say their most inside function is going to be this piece. And so, I don't know, let's call it our h of x. And that's going to be a negative 0.259x. And then the next piece will be that. And if we call that g of h, that's going to be 1 plus 36.797 e to the g. And then we have our total outside function, which is going to be the s function of g. And so that's going to be our 1342.077, and it's times g to the -1, because we're going to go ahead and say it's to the -1 now. Okay, that way it's easier to take our derivatives. Now, what do we need to do? Well, we need to take a derivative of all those: h prime of x, g prime of h, and s prime of g. So this is going to be a negative 0.255. This one is going to be 36.797 e to the g. And this one's going to be a negative 1342.077 g to the -2. Okay, that looks good so far. Now we just have to multiply all those together to get our, what we want is, because it's going to be s of g of h of x, And so then we're going to have ds dx is what we're looking for because we want that and we want that. So it's going to be ds dx equals, and now it's going to be ds dg times dg dh times dh dx. And so that's going to be a negative 1342.077 g. Well, let's go ahead and put that g on the denominator already. G to the negative 2, which is over g squared, times, and now our dg, so that's times, let's put it in parentheses, 36.797 e to the g times negative 0.255. Okay, now we're going to have to go to the next page. And let's first multiply here. So we're going to have a negative 1342.077 times 36.797 times a negative 0.255. And so that gives us a positive. So now we're over here. So now we have ds dx is equal to, that was going to be a positive 12593.024. Okay. Now note that if we used all of the decimal places here, then this value will be different. It's going to be off by, it could be off by half almost even. But that's going to be the kind of the difference there, depending on if we only use those 3 decimals or if we use the full values from our thing. So if we used, you know, if we used that whole thing. If we used all of those, that's going to be a different value. That's 258. How did I get 25? That's 259. That's a 259. Then I could throw off my numbers too. So let me change that 255 to 259. All right. So does that change anything? Yeah, it gives me, instead of this, so if we use that 259, that does change it. So even that 259, 255, that you're going to see that there's a difference. That's actually now 12790.561. And if we would go all the way, decimals all the way along, it's going to even be different. So, that's going to be a key, that things are going to be not always what they seem because of rounding. So, maybe it's always best to use all of them, maybe not, I don't know. It'll give you a more accurate answer anyway if you do. And then so that's that times that times that. So now we need e to the g on top also. And so it's going to be e, and what is our g, because we're going to have to replace that. That's this value, and so that's going to be to the blah, blah, blah. Now we're on this. Wait a minute. Do I have all the things labeled here? That's e to the g. Okay, so I've taken that number, so it's e to the g, so it's e to that. So it's e to the 0.259 negative. And no, yeah, there's an x. Okay. All right. And so then that's times, oh, we're put it on a denominator already, so we'll put it in the denominator. I'm just kind of going back and forth 2 pages is hard. So I've got that, and I've got that, and I've got that. Now it's over g squared, and so it's over this whole thing squared, and so basically then that's all over the 1 plus 36.797 e to the minus 0.259 x and squared. All right, so now I think I've got the number e to the power over that whole thing squared. Okay, so that's my derivative. Okay, now what we need to do is, it says find it for noon, 10, and 4 a.m. All right, noon, what's that going to be? Well, that's going to be 1 hour after that, so we need a 7. So let's go over here and we'll say we need a S prime of 7. What else do we need? We need 10 p.m. Okay, so it's 17. So we need S prime of 17. We need midnight, so that's going to be 19. And we need a 4 a.m., so we need a 23. All right. So now we just plug it all into our calculator. And so we'll take 12790.561 and then times e to the negative 0.259 times, and now we have it times 7. And we have to remember arrow down, divide by 1 plus 36.797 e to the negative 0.259 times 7, arrow down again, and then that whole thing is squared. All right, and so when we do that, that is equal to, again, with all my rounded numbers, 42.543 calls per hour. And then if we change everything to with a 17, that will give us 74.423 calls per hour. And if we now change it to 19, that gives us 57.979 calls per hour. And if we do one last one of 23, that gives us 27.593 calls per hour. And again, because we rounded here and these are all rounded, these aren't going to be, if you look in the back of the book, probably these won't be the same values as they have, because they're going to have a different number here based on, they used the full numbers to actually get to the point where they actually got those. So that would be B. Now C, let's see, discuss how rates of change might help the sheriff's office schedule dispatchers for work each day. Well, we can see that, when calls are getting higher, the rate of change is getting the highest. That would probably be the best time to have more dispatchers. When the calls are the lowest, you probably don't need as many dispatchers there. And so I think that would be the main way to do it, is looking at the rate of change, and the higher rates of change are going to need higher numbers of dispatchers, lower rates will need lower number of dispatchers. So that's how I'd look at it. I'm not going to write it all down because that's going to take a long time, but that's what I would do. Probably, here the going to be a higher number, even though, that's lower. It's starting to get higher, and then it's not as getting as many. So, you know, there are more calls in this area, but it's kind of the rates of change is kind of how you kind of need to look at that. So that's going to be what I would say. All right, we'll stop and come to this one.